Hello guys, welcome to PVS the TUTOR. Today under chemistry we are looking at calculating mass, number of moles and volume from chemical reactions and chemical equations. I have a question which says 2 grams of calcium will react with water. Write a balanced chemical equation for the reaction. So before we go any further, we need to remind ourselves that number of moles in any given compound or element is equal to mass over molar mass of that compound. And we also need to know that number of moles is equal to volume of that gas over the volume of that gas at RTP or at STP. So we need to take these two into consideration. So that's how we're supposed to go. So it says write a balanced chemical equation for the reaction. Calcium Ca plus H2O react with water, forming calcium hydroxide plus hydrogen gas. Now we need to check if the equation is balanced. We have 4 hydrogen atoms on the left side and we have 2 hydrogen atoms on the right side, so we need to put a 2 there. Then the equation is balanced. They didn't say put state symbols, they just say write a balanced chemical equation. If they wanted to say put state symbols, calcium will be solid, water will be liquid, calcium hydroxide will be aqueous, hydrogen would be a gas. Now, since we have a balanced chemical equation that we were asked to, we can now go on and find the number of moles of calcium used. That's B1. Calculate the number of moles of calcium used. We know that moles is equal to mass over molar mass, and this will lead to the mass of calcium that was given is 2 grams, while the molar mass of calcium is 40. When you divide, that should give you 0.05 mole. So we have 0.05 mole of calcium that were used in the reaction. B2 says mass of the slacked lime formed. Calcium hydroxide, that's slacked lime. Now to find the mass of calcium hydroxide, we need to take into consideration what to call the mole ratio. Look at calcium. You've got 1 mole there. Look at calcium hydroxide, we've got also 1 mole there. So we can say calcium and calcium hydroxide, they're in a ratio of 1 to 1. Because we are depending on calcium because calcium is the one which has got the mass. If both water and calcium had the masses, we could have found which one is the limiting reagent. But in this case, only one only one element was given the mass, that was calcium. So all our calculations are going to be based on calcium. So we're saying calcium and calcium hydroxide, then they're in a ratio of 1 to 1 in terms of number of moles. Then when we look at the number of moles of calcium that were used, that was 0.05. Here we don't have. Now since they're in the same ratio, it turns out that even calcium hydroxide has got 0.05 moles. If it's calcium hydroxide has got 0.05 moles, what do you think is the mass? So mass of calcium will be equal to number of moles times the molar mass. And moles, that's 0.05 times the molar mass of calcium hydroxide, that is 74. And we are going to have 3.7 grams. So we are going to have 3.7 grams of calcium hydroxide used. So take note of mole ratio and this formula. This formula came from number of moles is equal to mass over molar mass. When you make mass the subject of the formula, it will lead to this. B3 says the volume of, it was supposed to be the volume of the gas formed at RTP. So it's supposed to be the volume of the gas formed at RTP. Now, the gas formed in this case, we're talking about hydrogen. The calcium which is here and the hydrogen there, they are all also in the same ratio, 1:1. So if calcium and hydrogen are in the same ratio as 1:1, that means even hydrogen has 0.05 moles. So if hydrogen has got 0.05 moles, that means we go back to the formula for volume. Volume is equal to number of moles times volume at RTP. Number of moles is 0.05. Volume at RTP is 24 decimeter cubed, or you can use 24,000 cubic centimeters. So our answer here will be 1.2 decimeter cubed, or when you take it into cubic centimeters, that will be 1,200 cubic centimeters. Take note of the formula and the mole ratio. B says at STP, since we already know the number of moles of hydrogen, so we'll say we know that moles is equal to volume and volume at STP. It can be STP or RTP. So to find our volume will be equal to number of moles, that is 0.05, times volume at STP, that is 22.4 decimeter cubed. And we are going to have 1.12 decimeter cubed, or you can have 1,120 cubic decimeters. So that's what I wanted. So for all reactions, whether the reaction is the equation is not, but this is the procedure on how you're supposed to do the calculation that is involving equations and calculation of number of moles. Thank you so much. See you in the next video that I'll be doing on concentration and number of moles in solutions, and volumes of solutions, also titration. So thanks so much. Don't forget to subscribe